In case, first off, I'd like to thank Hootsuite for hosting our first speaking event for 2015. There are a lot of you here, and there's actually a lot of new members. I think in December we finally broke 2,000 members in the Polyglot Vancouver group, so it's a very, very large community. So that's pretty exciting, at least for me. I'd like to thank Bear. So specifically, like most of these talks, especially in the beginning, we used to go out and literally beg people, hey, you want to give a talk? Hey, you want to give a talk? And that has evolved significantly, and we have a network of people who really care about the community, and people like Bear Kai of Hootsuite, who end up encountering people like Peter, and are like, hey, you should really come out and talk to this group. And so thanks to Bear, we have, and Percona for agreeing, we have Peter tonight. There's still the reading group. It goes on off in a side channel because it's hard to scale a reading group, or rather a discussion group, up to like a room this large. So if you're interested in reading and discussing papers every first and third Monday of the month, these papers cover computing science, software engineering, and so on. Come talk to me and I'll tell you how you can join. We have a hack night that runs, and we could use some mentors. So if you'd like to mentor people in something, come talk to me, and then maybe we can connect you with some people, and you could take up some space in the hack night and help these people learn whatever they need to learn. Lastly, because there's all these members and we've had all these past events, some of you may notice we've been recording them, and thanks to one particular volunteer from the community, Gary Lucas, he's been slowly putting up the videos online. So there's a YouTube channel for Polyglot Vancouver, and if you'd like to check out the videos, you can. So, sorry for all that. If you have any questions, just come ask me, but without further ado, Peter Zaitsev.
Okay. I also want to say thank you for the Polyglot group for inviting me here. That seems like so. Hope you will enjoy my talk as well and won't regret coming here. I also wanted to say thanks to Hootsuite and Bear for really hosting that. Thank you guys. And then. The other important thing is let's keep it interactive. So just wave, ask questions, do something else. So it's fun and interesting for everybody. And then we will give away this high-performance MySQL book to one of the lucky active participants. Okay, so our sales team, can you guys wave or something? So if you want to talk business, talk to them. If you have some technical questions, that's to me, right? So what are we going to talk about? This presentation is called Architecture Design for MySQL Powered Replication. I'm going to cover three big things. First is what kind of tools and technologies do we really have. Then what kind of questions and what kind of thinking you can have when you are designing your application. And finally, we'll look at some most common MySQL architecture patterns which you can see in use today. First, let me start with this picture, which I grabbed from a presentation of the Architecture of Life journal about 10 years ago. Right, maybe even getting close to 11 years ago right now. Now, what is interesting for me about this picture? Well, if you look at that, there is a lot of very common components of that architecture which you'll find in use, maybe with different versions, right, of software, but the same components are similar which are in use today. We have a load balancers here, we have some sort of a front-end and back-end separation for web servers. We have a caching through Memcached. Anybody still use Memcache? Oh, okay, yes. So we have a global database for shared data, sharding, and read-write splitting, right? All pretty common technologies. Now, what does that tell to me? Well, that tells to me what the MySQL is really quite mature database, right? There is a lot of architecture patterns which have been in use for a rather long period of time, and they prove themselves as working, which is important, right? Because really when we try to innovate and try something, until it was out there for a few times, we can't be sure what there are no hidden problems, right? I've seen so many times when we roll out some solution and then, few years, right, a month later, you say, wow, now we need to do X. And that is very, very hard to do, right? So what it also means is what if you are building your application on the MySQL, is what most programs have already proven solutions, right? This may be not that fun because there is not really much place for you to be a hero in the MySQL ecosystem. But if you are looking for some serious engineering, right, where you can really have a sort of guaranteed success if you are using the best practice, the MySQL is a very good choice because you can essentially take some architecture off the shelf, right, from the book, right, or some blog post, implement that, and it probably is going to work for you because it has worked for so many people out there. Now, certain things has been changed, and let's look at the changes. Now, one is what has changed for those 10 years is what we have a hardware which is much more powerful those days. Like, if you look at 10 years ago, 16 gigs was a lot of memory. Now, you can get pretty commodity service run, not a big deal with maybe half a terabyte of memory. You can get maybe quarter of terabyte even in the cloud, which really kind of like in Amazon Web Services, which kind of a little bit trails the physical hardware you can get. We can get also very fast storage. If you look at the some time back, getting your directly attached RAID, you could get maybe 1,000 IOPS a second. Now you can get a flash and even related commodity one, which can drive more than 100,000 IOPS per second. Frankly, often more than MySQL is really able to use. And what is also very interesting is what the latency also has drawn dramatically, and that is very important in a lot of use cases, specifically in the MySQL environment, because in many queries MySQL executes them sort of sequentially, right? So it will issue I/O operations one after another. So in the past, if you would have some very big EMC array, right, with 100 of spindles, it could potentially do a lot of IOs, but it wouldn't really do you any good for MySQL workloads because you wouldn't be able to provide enough concurrency to drive them. Make sense? Come on, guys. How many slides? It's slide number 8 and not a single question. Nobody wants a book, I guess. Another change is the CPUs. Right? At that point in time, we had like 4 cores, which was typically 4 sockets, was a big deal. Now we can get 32 cores and up. In a MySQL environment, right, we typically have 2 socket CPUs, and that could go to, I think the latest release have up to 14 cores, right, and 28 threads per socket. That gives us 56 threads, which you can get in pretty commodity hardware. So a lot of concurrency. I mean, CPUs didn't become really that much faster, but they really become much wider. So what else is important? Well, if you look at the history here, looking at 10 years back, we had a lot of really struggle with the software. I mean, if you look at the MySQL, it wouldn't scale to even 4 cores. So it would have a file system which would be kind of quite crappy, right? Which wouldn't scale, would have all kind of other problems, right? And Linux kernel was, 10 years ago I think it was more or less good, right? But it became much better. So, but what the good thing is, if you look at the software across all the stack which powers your database infrastructure these days, it became pretty reasonable and is able to use that advanced hardware quite well. Now the next change is the cloud. Anybody runs here MySQL in the cloud? Anything else? Other part of infrastructures? Okay, well, so it is quite common, right, those days to run MySQL in the cloud, and that really allows us to do or to implement some very different approaches to MySQL, right? And in database in general than we could have before. One is what is very important is access to dynamic scalability, right? We can get more power for database and for application service on demand, which was much harder to do previously. In a lot of cases, you would have to wait for months if you have to get a new service in data center, right? Another thing what we like a lot is the throwaway server mentality. And what I mean is, if you get a virtual instance of a server, something that doesn't work with it, there is some sort of problems, you don't have to really try to troubleshoot and figure out if it's software, hardware, firmware, right? You just can say, okay, let me throw away that instance and get another one. Right? That's also allows really us to be much more efficient and agile. Right? I mentioned the less response for ordering and replacing hardware through dynamic scalability, but that allows the agility as well. If some of you decide, hey, there is some, I want to do this kind of interesting experiment, right, a problem, and it just requires or 10 servers, right, or 50 servers, you can spin it up in the cloud today in the evening with, almost no notice, right? That allows a lot of agile approaches, such you can test things at relatively low cost, right, and do all kind of experiments which in old environment, in the kind of physical data center, often we wouldn't simply have enough spare hardware to do that. And that also made a lot of operations much less involved, because right now we're not working with physical hardware, which have to be kind of pulled out, fixed, but rather with logical instances. Very handy. Now, one specific example related to MySQL, which I wanted to bring in, is how do we run migrations those days, right? Let's say you want to upgrade from MySQL 5.5 to MySQL 5.6. Anybody in MySQL 5.6 here already? 5.5? Okay, more 5.5s. 5.1? 5.0? Yes, there's some proud person on the back out there. 4.1? No? Yes, I think that's where we stop in our Dutch auction, right? 5.0, no, nobody goes below that. But anyway, so if you decided to upgrade from MySQL 5.0 finally to MySQL 5.1, right, because that's the latest release we can trust, then how can we do that? Even if you're doing that without cloud, right, in conventional environment, that can be pretty elaborate process. We'll upgrade our slaves one by one. We're kind of confident with that. We finally upgrade master, hope nothing breaks, and so on and so forth. Now, what we can do in the cloud is actually we can build our whole let's say, cluster, right, like master and bunch of slaves. Using the new MySQL version, we can test it out and whatever we want to do, and then we can essentially just switch from one old cluster to new cluster, right, and go back if it doesn't work. And in fact, what we just doubled our database hardware for a few days probably is not going to really blow up a budget, right? So we can often afford that and do much more safer and easier. Now, another big piece is of course automation. Right? Automation is very important for an efficient process, and I think it's very important to look at that in the all stages, in your development, in your testing, in your deployment, and in your operations. Right? So that is a big change. Is what we do have a lot of good tools right now which we didn't have before. Like if you look at the 10 years back, we would have some big guys like, think Google, Yahoo, right? They of course had to automate because on their scale it was inevitable, at least for operations, but it often would be some crazy custom scripts, right? Now we have a lot of tools to deal with that. Now, another interesting change is what we are getting some new languages and frameworks available. And again, what a lot of focus those days is being more agile and more productive in development. What I also can say, what we are writing a lot less of a system code. And what I mean by that is if you take a look, let's say, 10 years back, we would develop, let's say, some application using PHP. One of the first things we'll do is we would go ahead and write our own kind of database abstraction layer, because we want to handle errors some way and so on and so forth, right? Nobody will write their application directly calling the MySQL functions, right? That is not convenient. Now, we don't have to do that. Pick a framework in your favorite language, and typically all those kind of infrastructure is already provided for you, and you can very much focus on your really application code. What is also interesting is what the client-side development became much more complicated, right? And this I think is kind of interesting from the database standpoint. What instead of our typical old approach and have requests to the backend web server, which would kind of go and generate a huge page, probably, executing tens, sometimes, hundreds, even thousands of database queries. Right now, we would often have front-end work triggering multiple API requests, which are themselves going to be relatively simple, right? What you also have with the new frameworks is what there is a lot less database dependence. And in this case, we're not only speaking about MySQL versus, let's say, Postgres. There are a number of frameworks which, through the object relational mapping, right, can support even both MySQL, right, and relational databases, as well as some NoSQL databases as well. So there is, from development standpoint, a lot of ability to write database agnostic applications. Now, let me ask you here, anybody use ORM here, or framework which does ORM? Okay, a bunch of people. Now, did you run in any problems with ORM, ever? Yes, yeah, well,
very much.
So, yeah, I mean, the ORMs is kind of, good and convenient for developers, but it's not particularly smart in a lot of cases, right? So that can be a challenge, right? What we can see, what there are developers with a lot less database dependence, which start to trust the ORM, do smart things, and push for applications which execute the horrendous queries on the database, or horrendous amounts of queries. So that can be often the problem. And I think the challenge in this case is because you have a lot of people trained to do front-end developers, there is a lot more developers who have a very limited understanding of relational algebra, right? Anybody knows what relational algebra is? Okay, so did you ever met developers who don't know what relational algebra is? Yeah, so that happens, right? And a lot of our developers may now come which are not very familiar with databases, and they sort of have a tools which tells them, hey, you don't really need to learn about the databases, but that works for simple use cases, and then that can cause a problem down the road, right? So that's, I think, a very important change. Now, another thing what we look at those days is what there are really multiple clients, right, for our application. A while back, you would just have your desktop browser, and that was it. Now you have a desktop web browser, mobile web browsers, which may have need for different presentations. Now, chances are that you have some sort of app, right, for your tablets and phones. And then there is often a very common need to implement some sort of API so we can integrate with other applications instead of the users, right? That typically drives us to from to more service-oriented structure, right, for API, and a little bit different use of a database than you would otherwise. So now this is the talk which is marketed as about MySQL, but that's not really only about it. I think the main pitch from my side would be to look and to use the different tools, the best tools for the best job. MySQL, as I mentioned earlier on, really powers a lot of very large-scale and successful applications. But now we have a lot of other tools which can be good for some other things, right? And I can mention a few of them. When I speak about the caching or implementing some other in-memory data structures, the memcache and Redis can do it much, much better than MySQL. We've seen people using successfully RabbitMQ for queuing needs. For example, Cassandra and MongoDB, these are kind of pretty well-known systems to use for when you don't need relational the data and different other data structures work for you. Hadoop is a very interesting ecosystem, right, which has lots of tools which both for data analytics as well as some other data management on the large scale. Anybody use Hadoop here? Well, some hands. We see a lot of people having their kind of operational data in the MySQL and then extracting that and storing in Hadoop, maybe with Hive or Impala, right, for large-scale analytics purposes. Another thing to consider if you want to kind of to stay in the SQL world is using the column storage engines, which can be much more efficient for the analytical queries. Specifically, there is a database called Vertica, which is the non-open source, but it's kind of free to use until 1 terabyte or so, which we see a lot of MySQL users who still want to use a very advanced and low latency SQL language, using that with MySQL. Now, let me talk about the HA options and what has happened out there. Now, yes?
So previously you were talking about polyglot persistence, effectively like feeding out to those other data stores.
Yes, that's right.
It's still like, we've been exploring this space, and at least for us, we've been finding a lot of difficulty finding an ideal tool for the candidate. Like, we've been looking at LinkedIn's data bus and Continuance, Tungsten, Open Replicator.
Yeah.
But there seems to be like the entire space of like being able to take a database and its change stream, and then being able to plug it into other change streams, whether you're talking about MySQL or Postgres. Except for Oracle's CDC, like there doesn't seem to be a lot of answers. Are we just looking in the wrong place, or is that just an underdeveloped area?
Well, I think there's indeed more development to happen in that that area. I also think that it is this way because in a lot of cases it's kind of relatively custom, right? I mean, you don't often just have your MySQL data which you go ahead and just load in something else. There is some sort of a transformation, right, which often happens to that, and that often gets some custom development instead of just off-the-shelf tools for that. So I think that's going to be continued to be developed. Now, in the MySQL world, for example, there was a release for Hadoop applier, right, for MySQL, which I think still is in better version, but I think it will change. Another tool which actually one of our guys has wrote, it's called FlexUse. But the piece what is interesting out there is extraction from a binary log when you can convert and do whatever you want with it. Okay? Yeah. Yes. No silver bullet, right? Isn't that always the answer? So, in terms of availability, right? So, anybody here cares about their data? Yeah, so the MySQL availability, I think, is something which was the most the most aggressive and the largest interest over the last few years. This is because I think with Oracle having acquired MySQL, it kind of get from the database which was kind of used by some web companies to something which is used for a lot of very business critical data. And so what that means is what, even if you may not have a lot of data and it may not be very high workload, the data really has to be never lost. Application has to stay, always available and secure, and that means availability becomes very, very important. Now, when you look at the MySQL, what do we have in terms of choices? Now, more mature MySQL replication. Now, anybody use MySQL replication like 10 years ago? Okay, did you like it? No. Yeah, so maybe you can find there are some existing problems right now in MySQL replication. But believe me, a few years ago it was much, much worse. Right? I mean, I can tell you when we first implemented the replication checksum tools and the PT table checksum and Percona toolkit, you would essentially come to any customer, run replication, run it on kind of their master-slave setup, which we think would be the same because they're backing up from a slave, right? And then you will surprisingly find that there is a lot of data difference between them, right? And as we go through that process, some of that would be operational errors, some as somebody with dirty fingers writing the slave directly. But a lot of that was also replication not handling some complex statements correctly, right? So now replication, especially if you are looking at the row-based replication, is very solid in terms of moving your data from master to the slave without messing with it. Percona XDB cluster and other Galera-based technologies, I think that's also another great new innovation. And why this is important, because it sort of first allows you to stay with you in the DB storage engine, which a lot of MySQL DBAs understand very well, and it's also proven themselves to be very stable and mature. But you can get this real cluster semantics, right? So with MySQL replication, I have master and the slave asynchronous replication. That means I never quite can be sure when the data makes it to the slave, which makes it a challenge in terms of failover scenarios. It also makes it a challenge in terms of when I can read from a MySQL slave, right? The data may not be there, and I can be just using the old data. The XRB cluster allows you to set up clusters as people from enterprise world would usually expect them, right? You have, let's say, several MySQL nodes, let's say 5, right? You can write to any of them, you can read from any of them. There is no stale data, there is synchronous replication. If one of the node fails, well, that's not a big deal, right? You can continue operating on 4 of them, and then when you repair the node, it will, or start a new one, it will automatically join the cluster, right, and get all the data from that. So I think that is a very interesting technology. Now, MySQL cluster. Anybody here uses MySQL cluster? Nobody. Anybody here tried to use MySQL cluster? Yes. How long ago?
3 years.
3 years. Okay. So in terms of MySQL cluster, it's indeed kind of still quite complicated, right, and relatively obscure. I don't know why, but I think Oracle also doesn't get it a lot of world about it, right? It's actually quite a cool piece of technology if you can figure out how to work with it. So that can be complicated, but I wanted to mention it because it also became much more mature, and especially there have been a very significant performance improvements for complicated queries in the last versions, in the recent versions. Okay. And finally, I have something proprietary cloud HA. Does somebody knows what I mean here? RDS, yes. So there are solutions like Amazon RDS, and actually, if you look at some other cloud systems, you often would have some other stuff, right, out there as well. But RDS is obviously the most common, which is relatively simple to use, right, and rather solid high-availability solution for MySQL, which hasn't been there before. Now, if you are looking at MySQL replication, yeah.
I'm not sure if you're planning to talk more about RDS later on in your talk, but I was just curious about what your opinion is of RDS and whether or not there's any reason that you see not to run RDS if you're going to be running MySQL on AWS.
Yeah, well, I think that's an interesting question, right? We at Percona have been kind of going back and forth on behalf of our customers, right? I think it's every month or so there is somebody which we're migrating from RDS to EC2, and then somebody we are moving from EC2 to RDS, right? Because there are, well, benefits and drawbacks in both cases, right? The RDS is good in terms of what it requires a lot less administration overhead, but it also provides you a lot less flexibilities in terms of what exactly you want to use, how much control you want to have, right, and so on and so forth, right? I think that is the main thing what we see in this case. Does that answer the questions?
What type of flexibility do these types?
Well, I mean, if you look at that, the choice of versions, what you can run, right, in terms of access to them, in terms of, let's say, give you an example, right? I mean, I often do some complex MySQL troubleshooting. I can run, for example, O-profile and see what the hell is going on where the CPU is actually spent time, right? I cannot do it with RDS. It's kind of, black box. If I can get some MySQL metrics, but if it doesn't help, well, I just need to get another instance, right, or a larger instance. There is nothing I can do to analyze it internally, right? That makes sense. I can tell though what a lot of things with RDS has become progressively better. A few years ago, it was kind of very much locked in, right? You couldn't replicate to RDS or from RDS, right? You couldn't really easily extract your data and so on and so forth, right? Now I see some of those things kind of being progressively improved. Now, another, I mean, I know that probably would be your next question. There is also this interesting announcement of RDS Aurora, right? And I can't really tell you much about that because it wasn't really made available yet, even for testing. I mean, it looks good on the paper, right? I think if that really works the way it promised, that would be very good solution, right? And that would be a very serious motivation for people to consider going to RDS. Oh, one more thing I think I forgot to tell about the RDS. Number of people have also financial reasons why they don't like RDS. The reason is a lot of people running Amazon AWS on the scale, they like reserved instances, right? Because that's something which allows to get it much less expensive. The challenge is if you have a reserved RDS instance, that is RDS instance, and you cannot use it for anything else. If you have an EC2 instance, then if you happen not to need the MySQL instance right now, let's say you want to run some Hadoop, right, or even web server or something, you can put that in a good use. It's much more general purpose. So that is another interesting thing. Any other comments? I mean, I'm sure there's some people here who knows RDS much better than me. Okay. What's that?
It has issues too.
It has issues too, right? Well, yes, everybody has issues, right?
Actually, I'm curious, any members of the RDS team here tonight? Yep. I knew there'd be at least one. There's Amazon's office has a lot of RDS workers in Vancouver.
Oh, okay. So you're from RDS? Okay, so why did they lie?
I'm pretty new member to the team, so I really understand what other people are doing.
Okay. So do you want to come out here and spill all the secrets about the Amazon Aurora?
I don't think I can talk too much about that.
Oh, okay.
I'm not quite sure what I'm allowed to talk.
Yeah. Okay. I have just one question, right? So I read what the Amazon RDS can do. Sub-millisecond synchronous replication between Europe and Americas, right? So how do you guys beat speed of light?
It's done between a single region.
Between AZs.
Yeah, if you're between different regions, it will be much slower. I don't think you can do it.
Oh, okay, yes. I understand. That works well. Always blame marketing guys, right? Okay. So now the next thing, even if you choose MySQL replication as your solution, right, which a lot of people do. Anybody runs MySQL replication here? Yes, well, yes, I think, and a bunch of other people just too lazy to raise their hand, right? I mean, typically, if you look at that, almost all the MySQL replications, right, which are not toys, they would be running MySQL replication. Now, MySQL replication is pretty bare bones, right? And if you're running that, you're probably looking for something to manage your failover process. And there are a few decent tools which are available for that these days. MHA is one of them. PRM is other. Another, I would actually mention two tools. We continue in Tungsten. We have pretty advanced failover management out there. And if you run MySQL 5.6, there is some simple management tools in the MySQL utilities, which come as a part of MySQL. Now, if you look at those two, they're kind of all a little bit differently. For example, MHA has a lot of kind of magic inside about picking what node to fail over, making sure it kind of processes all the records and so on and so forth. While PRM is based on a pacemaker and has a lot of logistics to handle very complex split brain scenarios, integration with like fencing to kill another node, which kind of stop response and so on and so forth, right? So depending on what exactly you are looking for, you really may want to use different solutions. Now, another question is sharding, right? Now, does everybody knows what sharding is? Okay. Well, so sharding, it would be essentially like partitioning data manually across many kind of boxes, right, or many clusters, whatever you want to call that. And if you are looking at running MySQL at a very large scale, that is essentially the only game in town. Because, I mean, you cannot just have a large enough instance to run the whole Facebook on it, right, or all Twitter on it, right, or whatever. So there are a number of solutions in this space. Now, the MySQL doesn't provide this kind of very standard sharding solution like some other systems made. There is a whole bunch of different choices you can use. Now, first of all is what I will call not quite MySQL. And what I mean by that is there are some systems which talk MySQL protocol, right, and which kind of target replacing MySQL for at least some applications, but they have been designed separately. I should mention Plastrix, MySQL, and Scalebase, right? All of those are kind of proprietary with some different benefits and drawbacks. Now, in MySQL ecosystem, we also have a lot of solutions on the proxy level which would do something like a sharding or maybe kind of simplify sharding, providing some sort of query routing and read-write splitting. I would say ScaleArc and Scalebase, these are proprietary solutions. The Tesora is something which was proprietary, but they sort of became open source a few months back, and they have pretty advanced sharding technology. And then there is also tools like MySQL Proxy, MaxScale, Proxy SQL. These are what I would say like not quite sharding yet.
Not related to sharding, but for proxies.
Mm-hmm.
Are any of them capable of providing, like, if you want to have seamless failover for master slave, if you're doing migrations, for instance,
mm-hmm.
like without dropping connections, are any of them sufficiently stable to be able to support that?
Oh, if you just want to do migration? Well, I mean, in a lot of cases, what we'll do in this case, that's their MHA, right? Those kind of tool from previous slides, right? If you look at those, I know we have a number of guys which use ScaleArc in this regard, which is, I think, probably the most mature, right? And out of those. Now, finally, there are some open source frameworks for sharding you can use, right? There is Vitess, there is JetPants, which kind of the sort of third-party open source solution with various level of activity. There is also something called MySQL Fabric, which is Oracle's in-house implementation to provide sort of an official solution to the sharding problems. The MySQL Fabric is called GA. I can say I haven't seen a lot of people who really use that in production yet. Anybody heard about MySQL Fabric here? Okay, some people heard. Anybody running MySQL Fabric in production? Okay, yeah, well, that's what I would expect. But I would be watching that because there is a lot of a good engineering effort put into that, and it can come across as a pretty good product right in a couple of years. So now let's talk about some questions which are important in terms of designing your architecture. My approach to that is somewhat agile, if you will, right? So if you look at the architecture, I believe it is very important to make some right decisions early on. We have seen so many cases where people have become kind of too agile, and they say, hey, we shouldn't think about anything but today, and they would make some decisions which would be very, very expensive to resolve later on, right? And just thinking a little bit ahead would be good. Now, the other thing which I see is some people try to really design architecture for what they're going to be many, many years from now, right? Called over-engineering, which is also a bad idea, right? The thing is, you don't really know what your application is going to be, right? Or what technology is going to provide more than, couple of years, right, tops. I would just accept what the first architecture which you'll design and implement is not going to be perfect, right? And you have to iterate that. So you just need to make sure what that is good enough to, keep you up and working, right, until you can get it. Now, the next item I will talk about getting some advice, right? And I know Nikki wouldn't like me for this slide. No? She will still like me. My point here is what often you'll see the companies, right, which do things sort of like a certain way, and it's often very good to get some of external advice, right? Somebody who's seen other systems, right, and may have implemented and implement what you are trying to achieve. But it's also, if you with consultants, many of them would always find some other things to do, right? So if you just get them, with no leash, that can be very expensive proposition. But if you use consultants to use them, smart, that can really often help you to build much more effective architecture than you could have done yourself, especially if you are, small organization which didn't have done something like that before. Now, what I like to look at application is look at few of what I would call dimensions, right? One is it's very important to look at the application scale. And what do I mean by that? Well, there are very large-scale applications, right? Again, use the same Facebook or LinkedIn, right? Those are very well-known, very large-scale MySQL deployments. And there are your pretty small applications, right? Just, I don't know, some tiny WordPress installation, right? Which is also powered by MySQL. And a lot of other applications is probably going to be somewhere in between, right? And that drives a lot of questions about what really you want to be, because designing architecture which is capable of Facebook scale is really very expensive, right? Another key thing is what high availability. That is a very good to think about that in advance, because that, making that as an afterthought can be expensive. Right? You can, when you start throwing availability requirements, you may figure out what you'll have, significantly higher costs, or some things just don't perform when you add layer of as much availability as you want. Right? For example, if you're saying, hey, you know what, I really can't lose the data, and I need to make sure what I can survive losing the data center. So you are speaking about, probably synchronous replication across the data centers, right? Well, that becomes quite expensive, right? And it would drive a lot of your other architecture decisions. And then the other thing, which I think is very important to consider, is the team experience. I believe what in the modern technologies there are, many ways to skin the cat, right? I mean, you can build the same application actually using .NET or use Java or Ruby on Rails, right? You can build application on MySQL or Postgres or MongoDB in many cases, right? So it's very important to consider what is your team capable of and confident, right? I have seen a number of people trying to force something on the team which was very foreign to them, right? If you like, and which caused all kind of problems. Now, if you think about the general thing, what we spoke about first, was you want to avoid over-engineering, right? Which is obviously going to be very, very expensive. One of the most common ways of over-engineering with MySQL is kind of thinking about the sharding too often. And I can tell you many times somebody comes to us and say, oh, yeah. And that's like real example, right? I'm not just trying to say something silly here. Somebody comes to us and say, hey, I want to shard. I heard Facebook is doing that and other guys are doing that, so I should do that as well. Okay, so what is your database size? Well, my database size is about 10 megabytes. Oh, okay. Are you growing quickly? Well, about 7% last year, right? And we are planning about the same, right? Right? And obviously the other data, like number of queries a second, were absolutely trivial as well, right? So in this case, somebody just gets this idea about what all the serious guys shard, and he would want to shard as well. While at 7% a year, you know what, he probably would never need to shard because hardware and software improves at a rate faster than 7% a year those days, right? So, yeah.
When I hear most often, I need cluster.
Cluster.
And then 10 megabytes of data and so forth.
Okay. Yeah, well, it makes sense. It makes you may want to need some sort of clustering even if you have a little data just for the sake of high availability. So that's also possible. Now, another thing on the other side, right, is you want to make sure that you have some sort of runway, right? I mean, you don't want to have your architecture, so you just starting your typical Super Bowl advertisement, right? And then your system just collapses, right? And your, CFO, CEO, right, or whatever other monsters you have, just come to say, what the hell happened, right? You just spend so much money getting customers in, and you can't serve them, right? So you want to make sure you have some architecture runway which gives us enough room to roll out new implementation. Now, how do you achieve that? I mean, that sounds kind of trivial concept, right? But that's not so easy. And what I often see as a problem is people don't really understand what is the growth rate, right? And what to plan for. I mean, in countless time I come in and say, okay guys, they say we want system to work quick, right, to work fast, scale well. I would ask, how much performance do you guys really want to get, right? How much scale you want to get? Oh, we want kind of infinite scale. I'm saying that's not the problem, guys. Give me infinite budget and I will build you a system which will work with infinite scale, right? I mean, and then from that point on, we can get some more concrete conversation, maybe involving a product manager or some other guys to get some idea about how quickly it's going to grow, right? In terms of data, in terms of users, and so on and so forth. And then we can do some capacity planning, some sort of benchmarks or some computations to say, hey, looking at your workload, at your feature plans, at what exactly is going on database, we can be reasonably confident what you can handle 3x without changes to the hardware. And if you boost your Amazon instance size, right, you can probably even go 5x, right, or something like that. That can be very valuable, right? you also have to be kind of careful with that, because all those kind of computations, they can be invalidated by a stupid developer, right, who doesn't know how to index stuff and pushes some nice code to production, and you have no capacity at all, right? Anybody's had that in their experience?
Yeah,
No, you developers never make mistakes?
I make mistakes, but unrelated question. So assuming your developers are smart, do you have any rules of thumb in terms of capacity planning that you found helpful?
Well, in terms of capacity planning, well, I would tell, in terms of capacity planning, probably the good thing is not to assume linear scalability. Right? So if you take a look at that and say, oh, my CPUs are only 20% busy, right? That means I can get 5x from this box, right? For lots of reasons, you wouldn't, right? So that is a good rule of thumb, right? If you look at that, in a lot of cases, I like to measure more than compute, because in a lot of cases you run into some surprises where something, in theory should work, but in practice, when you put the system under load, you get some unexpected bugs or something like that. Right. So that's the second thing. Now, another interesting thing in terms of rule of thumb, right, I would mention is when you do your kind of math, you have to account typically for the data size increase as well as the load increase, right? In a lot of cases, I see people, I need to handle 2x the load, right? What that often means, I want to handle 2 times of query, twice as many queries on twice as much data. Or maybe data is actually going to grow even more than 2x, right? That has a completely different implications.
I was going to ask a follow-up question about, so if you're taking the approach of measuring and testing, do you have any suggestions for ways of simulating your expected load? So you have an idea of what your growth rate is going to be. How would you simulate?
Yeah, well, this is actually rather tricky, right? I would say the best way happens in the shard applications, because in that case you can essentially just create a bigger shard, right, and see how it behaves, right, and sort of kind of pick some guinea pigs, right, and work on them. Now, what we also often would do is we have a bunch of tools, PT log player and also Percona playback, which is kind of quite silly tools which will allow you to grab the queries even from TCP dump traffic, right, or from the log file, and then replay them concurrently, so you can see how it behaves. And then what I would usually do, either to scale the MySQL configuration, say, okay, what happens if I get this guy half amount of memory, right, or a quarter? This usually is a very good proxy for your kind of increase in the data size. Or if I want to really test the increase in the data size, I can essentially load my data in, let's say, 5 different databases on the same instance, and start to load 100 all of them in parallel, right, to see how that behaves. I mean, it often gives some good ideas. Okay. Okay. So, high availability. Now, I think it's the interesting concept, right, about the high availability is what everybody wants them, but few people want to pay for that. Because if you speak about the real high availability, right, I mean, call it like military grade, right, or kind of space grade, that becomes really, really expensive, right? And that is not just a question of your software, that becomes really the process of your whole process have to be very fine-tuned for this, right? If you look about a lot of those highly available applications, they would have things like they kind of very, very test their software before they they deploy, because you know what, new queries or something can expose the bugs in the software which can bring your cluster down, right? Or again, developers pushing out some bad queries can take the system down. So my take is, if you're really looking at the 5 nines and more, right? And not just as SLA like, where people just say, oh, who cares? I mean, we had a little bit more downtime, we'll just pay people off, right? Give them 1 month free. If that's really important for you, then that's going to be very expensive. Now, at the same time, medium level of high availability is becoming much more reachable those days, right? Think about the solutions like Amazon RDS, right? Or solutions for MySQL Replication. They can significantly improve your high availability, especially in terms of protection from your database failure, right? But they can't solve everything. And another thing what is, I think, very interesting in the MySQL case is what people are often going to be ones who is responsible for downtime. Now, I think it's interesting. I read the research from guys like Facebook who run, many thousands of MySQL instances. And in their case, for their workload, they had the mean time between failures of a single instance in MySQL was like 5 years, right, or so. So that was very much very mature and didn't crash a lot, right? And if you kind of scale that down for a lot of our medium-scale environments, right, you'll see what that MySQL wouldn't really crash that often. And what we see, especially in the smaller environments, is what some sort of mistakes, being that developer not properly testing the code, right, pushing that, some ops mistake where somebody logs in and drops the table on their own server, right, or run some, oh, okay, you did that, right?
When you say crash, are you including table corruptions?
Can you repeat the question as well?
What's that?
Repeat the question as well so they can hear it at the back.
Yeah.
When you talk about crashes, are you talking about table corruptions?
When I'm speaking about the crashes, do I talk about table corruptions? Well, so in this case, that was included, right? Because MySQL would crash on the in a DB will crash on the table corruptions, right? But this is pretty. The table corruption itself is a pretty rare case, right? And it's not cause of some hardware-related issue, right, or operation system-related issue. Does that answer the question? Okay. Anyway, so people can bring the systems down, right? And I think it's very important when you think about your high availability to make sure you have a proper process setup tools, right, to avoid that from happening, both from development side as well as from operation side. Yes?
Coming from the developer side, we use a lot of continuous integration tools for just kind of testing our code, but there's nothing necessarily that we're doing that's focused specifically on our SQL databases.
Yeah.
Is there any tool sets that you recommend?
Well, what I can tell is one of the tools we have is called Percona Cloud Tools, which is currently in beta, but it still works pretty well. What that allows us to do is to discover the new queries, right? So what I would like to see in a CI or something is what you would discover the new queries which haven't been run before, and then have some sort of DBA to look at that and say, hey, that is actually how you would run this query. Or say, oh my gosh, what the hell you're doing? That is, the query which is going to be very bad. So that is a good process. Now, if you don't like the Percona Cloud Tools, want something command line, we also have some support for that in the Percona toolkit with PT Query Digest, where you can sort of build a list of queries and then run it again, and it will kind of discover which queries have been new. Yes?
What sort of solutions are there any for MySQL if you want to have a multi-master system, like multi-master replication?
MySQL solutions for multi-master replication, right? So, well, the multi-master is very kind of which is used in different ways, right? So we often see MySQL normal just replication set up as master-master but active-passive. In this case, MHA, like a PRM, can be used in such configuration pretty well. Now, if you're trying to do MySQL replication and active-active, my advice would be don't. All right, because asynchronous replication with master-master active-active causes a lot of problems, right? Which is typically just not worth it. Now, synchronous replication with master-master actually can work pretty well, right? I mentioned already the Perconnect Ruby cluster. With that solution, because we have essentially synchronous replication, you can write to multiple nodes at the same time. Does that answer the question? Yeah. Okay. Sounds good. Yeah, so we spoke about the team experience, right, and spoke about the process already. So the key again is what people can bring your systems down, make sure what you have your right process and developments, right. You're having some process and continuous integration to catch the bad queries, right, before we come to production. But then also assume what you won't catch everything. Make sure there is some operational process to catch that queries. And the reason for that is what some of the queries maybe look quite well initially, but because of, for example, MySQL bugs, they will cause some problems really in the production down the road. And it's very important to have some tools to deal with those, right? One of the good things I would mention here is in the Percona toolkit, we, for example, have a cool tool called PT-kill. And what it allows is to set up, to say, hey, if I have some very, very bad query, why don't I kill that query instead of just letting it to take a, run out of disk space for temporary tables and take the whole system down, right? So some sort of those kind of tools of a last defense can be very helpful as well. Now, another key for architecture, and that kind of goes to your polyglot stuff as well, is simplicity. Really, the less components you use, the simpler it is going to be in terms of your complexity to maintain, especially in the small team, right? If you have like 50 engineers, you can probably afford to have 5 people who know MySQL and 5 people who know Cassandra, right? In the small teams, it's much harder than that. And I have a story here as well, right? I remember visiting one customer, and he says, oh, you know what? I need to do some logging, right? Well, and I heard Cassandra is very, very efficient for doing writes. Oh, okay, yeah, that's, that sounds about right. So then I would ask him, okay, but how much do you write? Well, we have about 10,000 log records a day, right? So obviously, example, at this point, it doesn't really matter what Cassandra is maybe more efficient doing that. At this workload, you can, probably put it in as simple solution as you're comfortable, right? Like SQLite would work just fine. Now, what is interesting in this case is I visit them again at that time, like maybe half a year later, and would ask, okay, so how is that Cassandra project is doing? I say, well, you know what, we had that developer who knows Cassandra and he left, and I think he still writes in logs in Cassandra, but we don't have anybody in the team who knows how to read data back and analyze it. Right, so, keep that in mind. So again, we're looking about every component which needs some experience, right? If you're really running production application on that to monitor and troubleshoot. Now, another thing with me is what I see a lot of developers, especially young developers, are getting very, very excited by the new technologies, right? Oh, I see some, people smiling, right? Especially great hair ones. Yeah, so that does happen, right? And really, if you're kind of development manager, you really want to be very careful to kind of keep it up on that, because you may get some very exciting technologies which will, you know, just not ready for prime time, or they may not ever become ready for prime time because they'll just die off. I would suggest, unless you really need to see what other people are using and follow the crowd. There is a safety in numbers, right? And there is such a great thing as a community support information in Google, right? And so on and so forth, right? I mean, if you just type in your technology name in Google and have like 100 matches, I would be very worried. Yes?
Does that include such popular things as Mongo?
Such popular things as Mongo. Well, I mean, in terms of Mongo does have a pretty large community, right? But in this case, I would say not. The large community doesn't guarantee, right, the success, and I wouldn't use that as the only metrics. Now, I would say is when you speak about the Mongo, right? Well, there are a number of people who are happy with Mongo, right? It doesn't mean not everybody is. The same thing as with an OpenStack. That's another interesting example, right? I see some people say, OpenStack, oh my gosh, we just try to deploy it, and that is such a nightmare, right? But and other guys I know have been quite successfully running that in you know, production for, you know, the year plus those days, and that works for them, right? So that's how it goes. Now, another thing what I want to tell is about the applications, about the large and small, right? I mentioned there are large applications, things like Facebook. And I would say that the majority of applications what we deal with those days by the numbers are relatively small applications. And what do I mean by a small application? Small applications would be the applications which can run essentially on a single MySQL instance, right? Maybe I will add some caching with memcache. I will probably add more than one instance for HA purposes, but from a purely standpoint, they can run on the, from a purely performance standpoint, they can run with a single instance. And I mean, there are a lot of such applications I run into, right? Like one of the like very large US companies, for example, have internet website where everybody uses that as a landing page, right, in the company when they start a browser and use it all the time. 200,000 employees, Drupal-powered application, you know, really MySQL behind all of that, utilization like about 1%, right? So you can really get a lot of mileage from MySQL those days. Now, let me do some math those days, right? How does that happen? Now, if you look at the MySQL instance, it's relatively easy to get to 100,000 queries per second, right? For reads. Now, this is not some peak number you can get at benchmarks. If you go to Oracle websites, they'll tell you, hey, we are able to reach 600,000 to like 700,000 queries a second those days, right? These are some numbers which are quite casual. Now, if you build in the model, modern website, right, with those kind of some, you know, JavaScript-based UI, you'll typically not look in terms of page views, but user interactions, like I click here or there. And even if you're looking at your 20 queries per user interaction, which I would say is quite a lot, we're looking at about 5,000 user interactions, right? That would mean a second. That means even if you look at those big split between night and day, right, as for a lot of application, we are looking at about 150 million of user interactions a day, and that can give us maybe 10 million of active users with a medium engagement, right? Which is quite a big number, right? So I think a lot of people don't realize how large-scale application you can actually build without going through this relatively expensive sharding process. Finally, let me talk about some practical choices you can look in terms of MySQL. And what I want to start with is some of a baseline. If I use the most simple MySQL architecture possible, what is that going to be? That's going to be a single MySQL instance with no cache and no availability and no various kind of supplemental technologies, right, to do everything else. This is the most simple, but it's almost kind of useless, right? Because we all care about the data and we would probably want at least some form of availability for any serious applications. So we are at least looking for some simple availability. What are our options if you don't really want to be there, build something very complicated? HA with database as a service, like as an Amazon RDS. Very simple, obvious choice. Availability with MySQL replication. Remember, safety in numbers, right? And I don't think there's any other availability solution for MySQL which is used as widely as MySQL replication. Right. Third is what you can use per corner XRDB cluster, which again gives us some relatively simple to manage cluster, which is also very easy to understand for developers in terms of what kind of semantics it provides. Now, in terms of scale, I think it's very important to understand, as your application grows, what exactly do you need to scale? And in most cases, you're going to scale all of them, but it may be from a different scale, right? So, for example, if you think about your data size, if you have something like newspaper site, right? Then as your application scales, you get more and more people visiting to read the site, your data size may not grow as much, right? While for other sites, something like a social, often your data size may go kind of continue kind of growing, right? Even if your use level stays the same. You also often be looking in terms of scaling reads and writes. For some workloads, you may see what my reads are going to grow much faster than your writes, right? And that's something which is important. Now, before you say, hey, let me just need a bigger hardware, I think it's good to understand it's a very good idea to see how you can manage the load. And the very good way to describe that is what you can move the load in essentially two dimensions, in time, right, and in space. In terms of space, that's very simple. You'll find a lot of query people taking the slaves and moving some queries to that. For example, reporting queries. Very nice trick, right? What you can also do is move some things in time to say, hey, there is some sort of process in which I don't have to do right now when my load is at peak. I can do it at night, right? And that's what I would say managing in space. In a lot of cases, kind of making your load more uniform across both your infrastructure and in terms of time can really help you to get much more from your existing application. The next thing is queuing, right? I think that is a very important architectural concept. And if you look at about any large-scale application, it will use a lot of queuing in its architecture, because that is really great. It can help us to deal with the load spikes, because if a significant portion of our workload just goes into a queue, then it will queue will grow, right, and then shrink in its own pace instead of causing us overload. It can also increase the reliability, right, because there is not a lot as much stuff which is underway, just put in the queue and then some other components going to process that. It also can help us to scale a part of the systems we need to scale. If I have structured my system so it uses the queue and some sort of like microservices, then often I can just scale the things I need. A good example would be with websites, something like YouTube, right? When you upload a video, it's not processed on the fly on a web server, right? it's put on the queue and then processed in the background. And if there's a lot of people uploading video, then that part of the infrastructure which has video processing workers, it can be scaled up, right? To get more workers so those can be processed. So it can be very helpful. And there are many solutions for that. I just mentioned some of them here. Now the next thing is scaling reads. What are our solutions for that? Replication, right? Replication and read-write splitting allows us to do a lot of reads from the slaves and being a very easy and very commonly used technology for scaling reads, right? Caching, memcache, Redis, in-process cache, or whatever, is really, really wonderful, right? I mean, caching stuff again. If you are looking to build a highly efficient application, using caching is very common to do. And then again, I would mention the Connex 3DB cluster with its kind of read anywhere concept. It can be very powerful to scale read without kind of dealing too much of a scale with stale reads, stale data. In terms of scaling writes, there are essentially two big approaches to that. One is what I will call a functional partitioning. And that is a fancy word, but actually it's pretty simple. Let's say your application has, I don't know, let's say website and a forum and like online store, right? But first you had running that all on a single system. But these are actually different applications which are not really tightly coupled, and you can put them on different MySQL instances, right, and get good performance gains those ways. So in terms of when you have relatively many components, right, and you just need relatively modest improvement, right, maybe 2x, 3x, that is often very easy thing to do. And then if you're looking at the really large scale, then as I mentioned, sharding one way or another is essentially only game in town. Now, when they speak about their scaling data, then it all comes to a question, okay, how much we can practically store on the single MySQL server. And that has a lot of implications and is really workload related. Sometimes it's going to be driven by performance. In other cases, it's driven by operation needs. For example, how long does it take to alter table, right? If it takes you a month to run the alter table on that single instance, then, I mean, you probably wouldn't be able to practically support your development team well, right? What about backup? How long does it take backups and restore, right? Because, you know, things can crash. If it takes you 3 days to restore backups, I mean, is that something your operational managers will going to be happy? You know, probably not. So that number have been changing significantly, and I would say those days I'm pretty comfortable with going up to maybe 10 terabytes per MySQL instance on the high end, right? In a lot of cases, because of the workload, it has to be less, right? Because we really need a lot of much more data in memory. So I wanted to talk a little bit about the technologies which really empower that those days. One is online schema change, right, which recently became available. This is available in MySQL 5.6 as well as PT Online's schema change for Percona toolkit allows to do that in MySQL 5.5. Now, fast backups. Fast backups means taking physical backups, right, in most cases. We have a Percona Extra backup, which is an open source backup. There is MySQL Enterprise backup. Does approximately the same things, but costs money if you prefer paying. Yes?
For the online schema change in 5.6 is effectively following the same, under the hood is effectively the same as the way PT Online schema change works?
Well, I mean, it's...
Can you repeat the question?
Yes, so the question is if online schema change in 5.6 is the same as PT Online schema change. The answer here is it depends, right? In some cases, when a table has to be rebuilt, then it does essentially the same stuff, right? It's rebuilding the table and applying the changes. In other cases, when you are just adding an index online, it is able to do it without rebuilding the table. So that might be different. Now, if you would ask the questions, if I'm running MySQL 5.6, is there any reason to use PT Online schema change? Then I would say, oh yes, we still commonly used. And the reason that it's more flexible in terms of controlling it, how much of a side load it will cause on the system, right? Because in many cases you want to do online schema change, but you don't want your foreground load to suffer a lot, right? You can tune that if it's online schema change. You can't tune it with an in-place other table. Okay, so yes.
Sorry, what exactly is online schema change?
So what is online schema change, right? I mean, if you look way back in the MySQL, right, a few years ago, you run alt table, for example, to add a column or an index. The table is blocked, right, and the process takes 5 hours, and that table is inaccessible for those 5 hours. You know, not very good for an application, right? Online, that means a schema process, schema change process go in the background, and table is still accessible, right? Does that make sense?
Yeah.
Okay. Going back to backups, then another way what we can do backups is modern volume managers and file systems, right? I mean, I know there's a lot of Amazon fans out here, right? So we can take, let's say, EBS snapshots very quickly, right, on relatively large volumes those days. Fast network, right? Anybody runs here 10 gigabit those days? Okay. Or that became affordable, right? And prices are coming down. Now, if you run a large-scale database, I would highly suggest 10 gig bit Ethernet. Even if you don't need that much for your normal workload, chances are you don't. But if you need to get the data quickly in or out of a box, right, backup or restore, then that is where fast network can be really, really helpful. High performance storage, flash and SSDs, I mean, you can really get ton of bandwidth and IOPS those days, right? I mean, as I mentioned, could be thousands of IOPS, and with PCI Express cards, you can get in more than gigabyte a second being written or read from the storage quite easily. And then compression is also helpful, right, in terms of amount of logical data which is available. InnoDB has compression, and frankly, InnoDB compression is not so good in my opinion. It kind of gives you mediocre compression with rather high performance overhead. If you're looking for compression, TokuDB may be more interesting storage engine. It is kind of designed from the ground up with good compression in mind. And TokuDB is available in Percona server, right? And it's also is supported by Percona if you need it. So to end this thing, as a summary, you can see what the MySQL is pretty mature, and there are quite good solutions available for many problems, right? So that is a pretty safe bet as a cornerstone of your application. Now, when you look at the architecture design, it's very important what you make a few right choices from the very beginning, whether yourself or with some advice. And it's also good to note what the hardware and software advantages over the last few years allow us to go rather far, even employing rather simple MySQL architectures. Now a few other things that I wanted to mention. If you guys are very interested in MySQL, right, and would like to learn a lot more about that, we are running the conference in Santa Clara in April. You know, consider attending that. That is a very good set of talks and tutorials about MySQL. And right now, that is a good time to get a ticket because we have an early bird price and ends in a week or so. Also, to give a fact, we are running the OpenStack live show, which is conference about the OpenStack. If that's something what you guys are interested in this polyglot group, right? That's we'd like you to attend as well. And thank you. That's it for me. I'm glad to take questions.
Questions from the audience first. We're going to go for food and drinks afterwards up at Brownstone's on 13th of Main. Who's interested in coming? Okay.
Okay. Any questions? Remember, I still have a book to give away. You know. Yes.
Do you have any tips or tricks for debugging replication latency?
Debugging replication latency.
Yeah. It's been very slow.
Well, you're speaking about the replication being slow in like replication lagging or what?
Yeah, just the data appearing on the slave like seconds after it's on the master.
Yeah, well, so when you have a latency in the replication, right? Like, first is it's good to see where you have a replication lag, right? If you would see that is, you can see that either as like there is a seconds behind master variable in show slave status on the slave, or you can also take a look at their in Percona toolkit there is like an end-to-end replication lag lag monitoring tool. Now, what can be a good thing is you can check how much your thread is loaded on the slave, right? How much that is busy. One easy way to do that is to take a look at the user stats, which is available in Percona server. You can essentially see how busy the slave thread is, right? And assuming what that is, the problem in your case, what replication cannot keep up, so you have a replication lag. What I will take a look is, I will take a look at the master to make a slow query log with long query time equals 0, and check out the Percona Cloud Tools or PT Query Digest to see which of the right queries take the most time. These are probably the queries which clog your replication thread, right? And if you can optimize them, you can make replication to run faster. Yeah, that's kind of a long reply, but I hope that helps you. Yes?
How do you validate the data integrity between master and slave in a real life system?
Yeah, so what we like doing in this case is we have a tool for that, surprise, right? It's called PT, the table checksum. So what that does, it can check the consistency between master and slave and do that online, right? So it doesn't kind of log master and slave and just does checksum. And it does it with chunking and can be done online. Typically, what we like is to maybe set it up to run only weekly basics, right, or something like that, so you can make sure the data is in sync. Same as kind of RAID controllers does, checking the things.
In case of a lag, it will fail, right?
No. So it works exactly. Even if it works with a very large lag, right? Let's say you have a lag of 1 day, it still will validate because it's essentially used the replication to check the replication consistency. It's kind of pretty smart. Yes.
Could you give a reference for a list of metrics and methods to deep dive into performance measures for MySQL. Are those in the book you said or somewhere?
Well, in terms of performance, well, I mean, obviously there is some stuff in the book, right? In terms of metrics, I like to look at that the following way. If you think about the MySQL, what is really the purpose, right, from a high level? Well, you want it essentially to answer the queries, right, and do that quickly. So where I like to look at is, first of all, is the queries. Again, using Percona Cloud Tools, so PT table checksum can give you that. And then I would look at why queries can be slow, right? And in that case, I would typically look at number of rows being examined by the query, or number of IOs that required, right? Or maybe number of rows that sent to the application. All those metrics can give you an idea about why the query is particularly slow, right? So that is, I think, is a good way for approaching this kind of thing, right? And besides that, the second kind of dimension of that is make sure that you're not doing something stupid, like check your MySQL settings. If you're running with MySQL defaults, if 8 megabytes ng buffer pool size, then a lot of things can go wrong, right? So validate those kind of settings as well. So this is kind of a big picture as much as I would look at.
The more specific things that I was looking, for example, yeah, the final result or final goal is to get queries running faster. But if you want to deep dive to have queries running faster, usually you get to these problems or memory problems, and there are a bunch of metrics to measure and to find out where the problem could rise. So I wanted to know if you can reference a source that point those metrics, especially for DBA of MySQL, if there's a collection.
Yeah, so, well, again, you would see that from the query details, right? I mean, if you look at our tools, you'll see what this query, it took, 25,000 IOPS, right? And it total contributed 7 seconds of response time. So you can say, aha, this query caused IO, right? You would see, for example, it created temporary table, and temporary table size was 7 gig. Okay, well, that's, that's probably cause of a problem, right? So that's what I would look at that, right? And again, there are typically a number of metrics you can use in the global, right? You can look about the disk IO hit ratio, right, or number of file sorts. The problem is, if you look at the global data, it's still not actionable until you can come to that and say, oh, that is the query which caused the problem and I need to fix that. Then it's not actionable, right? Okay. Other questions? Okay, I see people just want to go drink beer, right? Yes, well, okay. I still got the book together. You know what? I have an idea. I have this guy up front who was like, writing all the time. He never stopped even for a minute. He took the best notes probably out here, and I think he just deserves a book.
I'll type them up for you. Thank you very much.
Thank you very much, Peter. All right, sorry. Here we go. Okay, so it's 8:13. I'd like to clear out at the latest by 8:30, so the wonderful people at Hootsuite who've been helping us put on this event can go home. Or if they so choose, join us at Mr. Brownstone, which again is on May 13th. So if you'd like to join us, we'll be at Mr. Brownstone's. If not, we'll see you next time.